Hello everyone, welcome to my class. Today we will start chapter 14. I will cover sections 14.1 in today's class. So let me start the class right away. First, quick overview. In chapter 14, we will study function of several variables. That is f from Rn to R, and we primarily focus on n equals to 2 and n equals to 3 to a lesser extent. Verbally, numerically, algebraically, and visually. If you remember, in our earlier chapter 13, we studied the vector functions. The vector function was going from R to Rn. So here we are going from multi-dimensional space to real lines. Awesome. So let me start with the definitions. Functions of two variables. A function of two variables f from R2 to R maps an order pair xy to a single real number f of xy, and we often write z equals to f of xy, and z is called the dependent variables. Quick example of a function of two variables: the volume of a cylinder v, which is pi r square h. So here the pi is constant, r and h are variables, so we can write this is function of r and h. Similarly, we define a function of three variables f from R3 to R, where x, y, z map to w, or w equals to f of x, y, z. I hope this definition makes sense to you. So quick example of function of three variables are temperature functions t, which depends on longitude, latitude, and time or altitude. Awesome. Next definitions: graph of function of two variable. The graph of function of two variable is called the surface, and the surface lies on R3, and it is denoted and defined by S equals to set of all x, y, z, such that z equals to function of x, y. Note that the graph of fxy lies in R3 and it satisfies vertical line test. Notice that all surfaces are graphs of function of two variables. So here in the visualizations, this is the domain and z equals to function of xy. So the set of all x, y, z, where z equals to fxy means the surface. This is the surface, and it passes the vertical line test. That means every vertical line parallel to z-axis crosses the surface only once. So I'm only talking this part here, just the ceiling part here. I hope it makes sense to you. Quick example: the sphere fails vertical line test. However, the upper half of the sphere does pass the vertical line test, and the function is given by z equals to radical 16 minus x square minus y square, as well as the lower half of the sphere. Then I need to put minus sign there. I hope this makes sense to you all. Now let's move on. We have already seen some graphs of function of two variables in 12.6, which is quadratic surfaces. Note that the graph of the function of three variables lies in R4, and so this is super hard to sketch. Another useful way to visualize the surface is by using the level curves or contour maps or topographical maps. So the next definition, let's talk about level curves. The level curves of function of two variables are the curves with equations f of xy equals to the constant. In other words, the level curves are curves of constant elevations above the sea level. So that means on z equals to f of xy, we put z equals to constant. That means the z equals to constant gives us the altitude of that surface. Quick example: the level curves of the upper half of the sphere, z equals to under the radical 16 minus x square minus y square, are the concentric circles centered at origin. The level curves are also called the z traces. Next, let's talk about traces. quick definition. The trace of the surface in a plane is the intersection of the surface with that plane. That is, a trace in a plane curve obtained by setting one of the variables equals to constant. Then there are three traces. X trace, we put x equals to constant on these equations. Y trace, we put y equals to constant in these equations. And z trace, we put z equals to constant in this equation. So then the visualizations here, this is the x trace, this is the y trace, and this is the z trace. So here, let me wave my hand here. We have a three-dimensional solid here, okay, and then one we are chopping this way. I hope this makes sense to you all. And one we are chopping this way, and one, the z trace, we are chopping this way on the height. I hope this makes sense to you all. Quick remark: in the map, level curves crowd together means the profile of the surface is steep there. The 3D analog of level curves are the level surface, whose equations are function of three variables equals to the constant. We put a w equals to constant. Quick example: the level surface of the function of three variables, which is f equals to x squared plus y squared plus z squared, or x squared plus y squared plus z squared equals to k, which are the concentric spheres with radii radical k. So we sketch the graph of the level surface. That means we can take the k equals to the particular value 4, and we can graph the level surface in 3D. Otherwise, the graph of this function 3 variable lies in the R4, which is super hard to visualize here. And we are familiar with the spheres here. Okay. So then with this idea, now let's do some example. Example 1. Find and sketch the domain of the functions a to b. So here a functions in part A, z equals to function of xy, which is radical 9 minus x squared minus y squared, and in b, f equals to natural log of 4 minus x squared minus 4y squared. So let's find the domain and sketch the domain of this function of two variables. Solutions: now to find the domain, let's say this functions under the radical for part A, 9 minus x squared minus y squared is greater than or equals to 0. We can define this under the radical. So solve this one. This gives us x squared plus y squared is less than or equals to 9. That means the domain is inside part of the circle of radius 3. So the domain is set of all xy such that x squared plus y squared is less than or equals to 9. And its range is z lies in 0 to 3. So x, y can be 0. So that means 9 is 3. Radical 9 is 3. Or x squared plus y squared can be 9. Then 9 minus 9 is 0. Radical 0 is 0. So I hope this makes sense to you all. Part B. To define the log functions, this 4 minus x squared minus 4y squared has to be positive here. Oh no, y is negative. No, this should be positive here. So then my inequality here, then x squared plus 4y squared is less than 4, then this is true. So only this is wrong here. So this has to be strictly greater. Then divide by 4, it gives us x squared over 4 plus y squared over 1 is less than 1. This is simply the interior of the ellipse. So the domain is set of all xy in R2 such that xy satisfies x squared over 4 plus y squared over 1 is less than 1. Let's sketch the graph quickly here. So here, inside the circle with boundary, inside the ellipse without boundary. I hope this makes sense to you all. Now let's move on. Example 2. Consider the functions f equals to under the radical 9 minus x squared minus y squared and answer the questions A to C. First part A. Write the equation of the level curves of the functions by taking z equals to k equals to 0 to 3. Sketch all the level curves found in part A. And C. Sketch a 3D representation of these images based on the several level curves found in A and B. So let's find the equation of the level curves. So solutions for part A. Given equation is z equals to under the radical 9 minus x squared minus y squared. We put z equals to k. So this gives us x squared plus y squared equals to 9 minus k squared. So these are the circles of radius radical 9 minus k squared, center at origin. So then let's put k equals to 0. This gives us x squared plus y squared equals to 9. Circle of radius 3. At k equals to 1, the smaller circle than the previous one. At k equals to 2, smaller than the earlier circles. And at k equals to 3, this gives us x squared plus y squared equals to 0. So that means sum of the opposite numbers equals 0 means both of these numbers has to be 0. So x, y, 0 means we are at origin. So now let's sketch. So here, I hope this is more clear to you all. So the first diagram here, that's the level curves. So at k equals to 0 corresponds to the circle of radius 3, center to origin. So here is the center, origin, and 1, 2, 3. This outer circle. I have this makes sense to you here. So k equals 0 corresponds to the outer circle. Similarly, k equals to 1, middle one, k equals 2, the inner one, and k equals 3 just the origin. And then let's draw the corresponding surface. Then mean here, let's pull all those circles upwards here. Let's pull all these circles upward. Then this forms this shape. I hope it makes sense to you all here. So this origin goes to this north pole where the center lives. Haha, I'm just kidding. So this center goes to this north pole, and this circle is here, and the middle one is here, and the bigger one is here. So the surface is the upper half of the sphere of radius 3. I hope this idea makes sense to you all. So now let's move on. Example 3. Sketch the level curves of the functions f equals to 6 minus 3x minus 2y. By the way, it's a plane. 3x plus 2y plus z equals to 6. Now solutions. Let's begin. To find the equation of level curve, set z equals to constant k. So we put here and here. 6 minus 3x minus 2y equals to k. Simplify. It gives us y equals to negative 3 half x plus 1 half 6 minus k. So it's a family of parallel lines with the slope m equals to minus 3 half. So when and the sketch is here. When k is 0, let's see here what happens when k is 0. When k is 0, I can put here. When this k is 0, or I can put here. Let's put here. Let's k is 0. That means 6 over 2 is 3. The slope is minus 3 half. So it's a decreasing line. So the 3 and then the 2. So that means the k equals 0 corresponds to this line. And if you take k equals to 6, then this part is 0. So then no y intercepts here. When x is 0, that means it passes through the origin. So then it passes through the origin. And so I have a bunch of lines stacking there. All lines have the slope which is minus 3 half. Awesome. It makes sense to you all. Now let's move on. Quick aside. To sketch the plane in the first octant is given below. Plotting the intercept points and connecting them, we get the following surface. I think we graph this in our chapter 12 also. Awesome. So now let's move on. Example 4. Sketch the level curves of the functions g equals to 4x square plus y square. First, to find the equation of the level curves, set g equals to the constant k. Then simplify. It gives us x square over k over 4 plus y square over k equals to 1. That means it's an ellipse where x-intercept is radical k over plus minus 2 and y-intercept is radical k. So I sketch here the k equals to 4 corresponds to this ellipse, and k equals to 2, k equals to 1, k equals to 0.25 and so on. And to sketch the surface, now I need to pull this one in 3D from R2 to R3. Then what I do, I just pull this, this ellipses up in R3, then this forms this shape here. I hope this makes sense to you all here. So this outer one goes to this outer, the bigger ellipse, and then goes smaller, and we know this equation represents the paraboloid opening upward, and which matches to this surface. I know it's a slightly trickier. We first draw the or sketch the level curves in R2, and then we just pull them to the R3 to find the corresponding image of the surface. So that's another way to sketch the surface. So we finish these sections. Thank you.